For a long time, people have wondered what life might be like on other planets. Now, with the James Webb Space Telescope, the best telescope ever made, we might finally get some answers. Proxima Centauri, our closest star system at only 4 light-years away, has a planet called Proxima b. Researchers have seen some weird stuff coming from it. These things look like artificial lights, which has scientists really curious. What are they? Could they mean there are smart beings living there? Let's look at the James Webb Space Telescope's findings. It spotted lights like city lights, and that could change everything. Right now, Earth is the only place we know has life. Ever since the start of civilization, humans have thought about whether there's life somewhere else in the universe. To check this out, American astronomers Jill Tarter and Thomas Pearson started a project called SETI in 1984. They wanted to pick up radio signals from other planets. Radio waves can travel super far, so the 42 radio dishes in California's Sierra Nevada mountains are listening for them. So far, they haven't heard anything definite. Then, the James Webb Space Telescope got launched, and that helped a lot. It's the biggest telescope we have, and it can check out planets around other stars. It's about 1 million miles away and has super sensitive equipment, so it might find some big stuff. A while ago, we didn't know about any planets outside our solar system. Now, we've found over 4,000. NASA says there could be millions more. One way to find life is by looking for plant life. When the Galileo spacecraft was going to Jupiter, it turned back to Earth and saw something called the vegetation red edge. That's a mix of red and infrared light that plants reflect. If a planet was covered in jungles like Earth, it would have a really strong red edge signal. The James Webb Space Telescope, JWST, will measure the red edge on planets in the habitable zone around other stars. That will tell us a lot about what's happening on those planets. The JWST can also see what a planet's atmosphere is made of. When sunlight goes through the atmosphere, some colors get absorbed. The JWST can see which colors are missing, and that tells us what's in the air. That can help us figure out if life is possible there. Life might be on planets that have air like ours, oxygen, nitrogen, and carbon dioxide. We can also look for weird chemicals that don't occur naturally. For example, if aliens were watching Earth, they'd probably see CFCs, those chemicals used in refrigerators and cleaners. If the JWST sees CFCs on another planet, that would be a good sign of technology. But life on other planets might be totally different from what we're used to. There are organisms called extremophiles that can live in really harsh places, like super hot or acidic environments. Most of these are tiny microbes. Planets like Earth might have a better chance of having life than planets with extreme conditions. So, it makes sense to look at those first. These could have liquid water and orbit stable stars. Our Sun is a yellow G-type star. These aren't super common and don't last as long. There are more red dwarf stars out there, which are dimmer and cooler. Planets around these stars might have more time to develop life. One of the first places the JWST will look is the TRAPPIST-1 system, which is about 40 light-years away. It has a red dwarf star with 7 rocky planets that are about the same size as Earth. 3 of those planets are in the Goldilocks zone, which means they might have liquid water. Even though TRAPPIST-1 is smaller and cooler than our Sun, it still gives off enough light. Because its planets are so close, Proxima Centauri might be the best place to find city lights. It's a red dwarf star that's 4.25 light-years away. Proxima is much dimmer than our Sun, so any planet with water has to be much closer to it than Earth is to our Sun. In 2016, scientists found a planet there called Proxima b, which is about 1.3 times the size of Earth and is in the habitable zone. But Proxima b might just be a dry rock because it's so close to its star, about 4.6 million miles. That means it gets hit with a lot of solar wind, which can strip away its atmosphere. Still, it gets enough light to have Earth-like temperatures and maybe liquid water. It's probably tidally locked, which means one side always faces its star. Proxima Centauri is about 18% as big as our Sun and only gives off about 5% as much light. To someone on Proxima b, it might look like a scorched rock. But if there's an atmosphere, there could be liquid water. Proxima b gets about 65% of the energy that Earth gets, it still might be the best candidate out there. The tidal locking thing means there's always a day side and a night side, so there would be big temperature differences. Also, Proxima gets hit with about 3 times as much high-energy radiation as Earth, including X-rays and ultraviolet light. If Proxima b doesn't have a magnetic field like Earth's, it might be hard for life to survive. But if things are just right, it could be okay. Unfortunately, models show that planets that are tidally locked might lose their atmospheres quickly because the gases freeze on the cold night side. On Earth, volcanoes can put gases back into the atmosphere, and magnetic fields protect it. We don't know if Proxima b has volcanoes or a magnetic field, so we can't say for sure if it has an atmosphere. But if it does have an atmosphere, that means there could be oceans, which makes it more hopeful that there's life there. Maybe there's infrastructure powered by solar energy on the day side to create electricity, light, and heat on the other side, which would be super cold and dark. When they found Proxima b, scientists started trying to see if it passes in front of its star from our point of view. If it does, we can measure its size and mass. That would help us figure out what it's made of. When it passes in front of the star, starlight might go through the planet's atmosphere, which would tell us what's in it. But there's only a 1.5% chance that it'll line up like that. The star itself is also pretty active, which makes things harder. Astronomer David Kipping from Columbia University says that Proxima Centauri has a lot of eruptions. These flares can heat up a rocky planet and make it give off infrared radiation. But planets like Earth give off specific infrared patterns. The James Webb Space Telescope is designed to find those patterns. So, Proxima b's infrared signature is really important for figuring out its atmosphere. The JWST is much better at seeing infrared light than Hubble, so it might be able to spot artificial lights on Proxima b's night side, even if they're super faint. The JWST could find signs of technology if they're in certain parts of the light spectrum. Proxima b's day side might be covered in solar panels that reflect starlight. As the planet goes around its star, the temperature will change a lot. How much it changes depends on whether the planet is just a bare rock. If it doesn't have an atmosphere, the day side will give off heat, and the night side will freeze. If the temperature difference isn't that big, it probably has an atmosphere. The JWST only needs about 11.2 Earth days of looking at Proxima b to get enough the first city-like light on the planet's night side to show evidence that intelligent life exists beyond our solar system. That could be huge. Proxima b might have some big secrets. Maybe the planet's day side makes a lot of solar power, and the lights at night are from a society with the technology to make it. Even if they do find artificial lights on Proxima b, researchers are going to be careful. There might be other answers. The JWST is a new for worlds far away, and scientists are getting better at these techniques all of the time. The lights might be natural, like reflections from volcanoes, lightning, or weird stuff in the atmosphere. It's important for scientists to keep testing their ideas. The JWST will keep watching Proxima b and other planets that might have life to get a better idea of their atmospheres and surfaces. If scientists do confirm that the lights are artificial, they'll spend years trying to figure out where they're coming from. If it turns out that they're from smart beings, it would be one of the most important moments in human history. Everyone's excited about Proxima b and other similar planets because it makes us think about humanity's place in the universe. If there are aliens out there, we'd have to rethink how special Earth is. It could start a time of global teamwork as everyone gets together in order to search the universe. It would also show how important space exploration is and motivate people to spend money on new technology to keep searching. For now, looking for city lights on Proxima b is a cool idea. Maybe we'll soon find out if we're alone. But life on other planets might be very different from what we have here. Some organisms, like extremophiles, can live in really harsh places. These creatures, mostly tiny microbes, can survive in hot temperatures or very acidic places. Since Earth-like planets are more likely to have life, it makes sense to look at those first. These planets might have temperatures that allow liquid water and orbit stars that are stable. Our Sun is a yellow G-type star. But there are more red dwarf stars, which are cooler and not as bright. These stars live longer, which gives life more time to start and grow. The James Webb Space Telescope will first focus on the TRAPPIST-1 system, which is about 40 light-years away. It has a quiet red dwarf star with 7 rocky planets that are about the same size as Earth. 3 of these planets are in the right spot where they could have liquid water. Even though TRAPPIST-1 is smaller and cooler than our Sun, it still gives off light like our Sun does. And because its planets are so close to it, Proxima Centauri might be the best place to find city lights outside our solar system. It's a red dwarf star that's 4.25 light-years away. Proxima is much dimmer than our Sun, so any planet with water has to be much closer to it than Earth is to our Sun. In 2016, scientists found a planet called Proxima b that's about 1.3 times the size of Earth and in the right zone for liquid water. But Proxima b might just be a dry rock because it's so close to its star, only about 4.6 million miles. That means it gets a lot of strong winds from the star that could blow away its atmosphere. Still, Proxima b gets enough light to have Earth-like temperatures and maybe liquid water. It also probably always shows the same side to its star, like the Moon does to Earth. Proxima Centauri is only about 18% as big as our Sun and gives off only about 5% as much light. It might seem like a scorched rock. But if it has air, it could have liquid water. Since Proxima b gets about 65% of the energy that Earth gets, it might not be as nice, but it's still the best place to look because of tidal locking. This means one side is always day and the other is always night, which creates huge temperature differences. Proxima also gets almost 3 times as much high-energy radiation as Earth, including X-rays and ultraviolet light during solar flares. If Proxima b doesn't have a magnetic field like Earth, it might be hard for life to survive. But if things are right, it could be good for life. Unfortunately, science says that planets that are tidally locked might lose their atmospheres quickly as gases freeze on the cold night side. On Earth, volcanoes help replace our air, and magnetic fields help keep it from escaping. Since we don't know if Proxima b has volcanoes or a magnetic field, we can't say for sure if it has air. But if it does, that means it could have oceans, which makes it more likely to have life. Maybe there's technology on the day side to make electricity, light, and heat for the night side, which would otherwise be freezing. Now that we know about Proxima b, people are trying to see if it passes in front of its star from our view. If it does, we can measure its size and find out if it's made of rock. During a transit, starlight could pass through the planet's air, which would tell us what's in it. Sadly, there's only a 1.5% chance that it's lined up right for us to see this. The star's activity also makes it harder to see. David Kipping, an astronomer at Columbia University, says that Proxima Centauri often erupts. Solar flares make a rocky planet absorb light and send it back as infrared radiation. But Earth-like planets around these stars give off specific infrared patterns. The James Webb Space Telescope is made to see infrared light. Proxima b's infrared signal is important for figuring out what its air is like. The James Webb Space Telescope is much better at seeing infrared than Hubble, so it might be able to see city lights on Proxima b's night side, even if they're as dim as ours. The James Webb Space Telescope could spot signs of technology if they're in specific colors that the star doesn't make. Proxima b's day side might be covered in solar panels that reflect starlight. As the planet goes around its star, it will go between day and night with big temperature changes. How big the temperature difference is depends on whether the planet is just rock. If it doesn't have air, Proxima b's day side would send out energy as black body emission, and the night side would freeze. If the temperature difference isn't that big, it means there's air. The James Webb Space Telescope only needs about 11.2 Earth days of watching to get enough data to see the first city-like lights on the planet's night side. This light might that smart life exists somewhere else. Depending on what we find, Proxima b could tell us a lot. Maybe the planet's day side makes a lot of solar power, and the lights at night are signs of a thriving society with technology.